Hi world, today we are going to discuss about a resistor. So what is a resistor? So it seems that it is a very small topic, but wait, it is a literally very big topic. So I'm going to put a series of video on it. So let us start this video. What is a resistor? Let us start this video. So what is resistor? So to put it quite simply, I have just written the definition of resistor over here. So the definition of resistor is an electrical component which stops or regulates the electrical current. Now resistor is a very common component. You can find it in radio, you can find it in a mobile, or you can find it in a laptop. You can find it in every electrical device. It looks like this. You can see this is a resistor. So what is the symbol of resistor? So the symbol of resistor just looks like this. Here it looks like this. Or the second symbol which you can see over here, this is the second symbol. Okay, this is the second one. Okay, this is the second symbol, this is the first one, this is this is the second one. You can find in every PCB this sign. So R1, R2, R3, R4 or R5. So this is just a resistor over there on PCB. If you have seen like this alphabet R1, R2, R3, R4 on the PCB, so it is a resistor over there. Okay, so it is a resistor over there. So it is a resistor over the PCB. So now resistor is specified by a term resistance. Okay, so what is resistance now? Resistance is denoted by the alphabet R. So resistance is the property of a material to stop or to regulate the electrical current. Okay, so resistance is also having one term, Ohm's law, which we are going to learn about in this video only further. So firstly we are going to see difference between resistance and resistivity. Now there is a term called as resistivity. So the term resistivity, and what is the difference between resistance and resistivity? So resistivity is the specific resistance of the material, and it is denoted by a Greek letter rho. So rho is having, means resistivity is having a formula. So it is resistance into the sectional area upon length. This is resistance over here. R is denoted by, for here in the formula it is denoted for resistance. Okay, resistance. And A is the cross sectional area. Okay, A is the cross sectional area. Sectional area. And L is the length of that material. Okay, so if we are going to substitute the units of various quantities, what we get here? We get this thing. What? P is equals to ohm. What is the so here resistance is having the unit, resistance is having unit ohm. Okay, the unit of resistance is ohm. Okay, and what is the what we can say, what is the unit of cross sectional area over here? Cross sectional area. So the unit of cross sectional area is meter square. Okay, cross sectional area. So for it we are going to take the unit meter square. Okay, so meter square. And for length we are going to take meter. Okay, meter. So here the formula over here will be resistivity is equals to ohm into meter square upon meter, or upon length you can say. So therefore we have just substitute the units of various quantities we get. Okay, so here we have substituted this. Now what will be the answer over here? The answer will be this is having m1. Here the value is 1. So what will happen, this 1m will be here cutted, means this is gone. So what is remaining over here is ohm meter. Okay, it is having ohm meter, means what, ohm into meter. Now what is here over here, what we can say, it is ohm meter. So resistivity, the unit of resistivity, okay, the unit of resistivity what is the unit of resistivity? The unit of resistivity is ohm meter. Okay, so definition of what is the definition of the resistivity? The specific resistance of a material or resistivity is defined as the resistance of the piece of that material which is 1 meter long and of unit cross sectional area. It is what it is? It is rho is equals to R if L is equals to 1 meter and A is also 1 meter square. Okay, so therefore this is the definition of resistivity. Now what we are going to take is, we are going to take the Ohm's law. Okay, now what is Ohm's law, or what we can say about Ohm's law? So resistance and resistivity has a term called as Ohm's law. Okay, so the formula of Ohm's law, or we can say the formula for resistance, is V is equals to IR. Okay, here we can say this can be derived for resistance also. So the voltage is directly proportional to the current flowing in it. Okay, the Ohm's law states that the voltage is directly proportional to the current flowing in it. Okay, so over here if we will see the formula, V is equals to IR. So here if I have to take out the volt, or I have to just take out the resistance, now I am connecting here a circuit over here, and it is a 1.5 volt LED. Okay, 1.5 volt LED over here, and I have just applied over here 9 voltage. Okay, so this will blow, the 1.5 LED will blow and it will not work. But if I will just put a resistor inside this circuit, means if I will just put a resistor over here like this, I will just put a resistor over here inside that, so it can work very easily. Okay, so because of this resistor, the current or voltage will drop to 1.5 or something like that, so we can make 1.5 volt and that LED can just glow, and therefore I can just on this LED. But I have to take out the value of the resistor. How I should, what value of resistor I should add there? So the value of resistance will be from the formula volt upon amps. So is equals to, it will be equal to what? It will be equal to 9 volts upon 2 amps. So here volt, V is for volt, and amps is for amperes or current. Okay, the unit of current is ampere, if you know. So this is equal to 9 volt upon 2 ampere. Okay, so we get here 4.5 ohms. So I am going to just take 4.5 ohms of resistor over here. Okay, 4.5 amperes, 4.5 ohms of resistor. Okay, so I am going to just apply here 4.5 ohms of resistor so that the circuit can work. So we are going to learn combination of resistance. Now what is the first case is, resistance in series. Now this over here you can see this is the resistance in series. This is a type of resistance in series. This is called as, for example, if you say what we can say about this is when a number of conductors, say A, B, C, D, F, etc. are connected end to end as shown in this figure over here. So they are said to be connected in series. Okay, so now for taking out the resistance in this circuit, this whole circuit, we are going to just apply Ohm's law over here. Now Ohm's law, V is equals to IR. Okay, V is equals to IR. Now V1, what we are taking here, the volt in the first resistor, volt in the second resistor, volt in the third resistor. Now V1, V2, V3, V1 plus V2 plus V3. Okay, so Ohm's law, we are going to apply Ohm's law over here. Now V1 is equals to I into R1 and V2 is equals to I into R2. V3 is equals to I into R3. Okay, so now V is equals to V1 plus V2 plus V3. Okay, now what will be the voltage? V1 plus V2 plus V3. Okay, so and what will be the this one, the formula? According to the formula, this will be the answer: I into R1 plus I into R2 plus I into R3 is equals to IR. Okay, so where R is the total resistance offered by the combination. Okay, so therefore if we are going to consider this, then therefore we can consider this also. R is equals to R1. Now what is the resistance will be? The resistance in that circuit will be with this 3 resistance, means this 3 resistance which is having here, we are going to connect, we have connected it in series, the resistance. So it will be the combination of this. Like I am having a resistance of 22 ohms in series. Okay, like this 3 resistors of 22 ohms I am having it in series. So what will be the R? The value of resistance will be 22 plus 22 plus 22. Okay, means what? 44, and here we are going to take just 4. So here we are having 66. Okay, the value will be 66 ohms. Okay, so the value of the resistance will be 66 ohms. 66 ohms. Okay, 66 ohms. The value of the resistance will be 66 ohms. How? Here we are going to just sum, we are going to take the sum of R1, R2, R3. Okay, like 22 plus 22 will be 44 and 44 plus 22 will be 66. Okay, so 66 ohms of resistance is applied over here. If we are going to take 22 ohms resistor in series. Okay, 22 ohms resistor. Now we are going to go to another case, which is resistance in parallel. Resistance in parallel. Now what is resistance in parallel? Now we are going to learn about resistance in parallel. So if this diagram, or if these conductors are joined to the same 2 points, it is A, C and E are joined together, and B, D and F are joined together, then they are said to be joined in parallel. Okay, the total current I fed into the system divided into I1, I2 and I3 flowing through the various conductors. Then it will, what will be the equation? I will be equals to, what I am trying to say is I will be equal to I1 plus I2 plus I3. Okay, so if V, here V, what we are having over here, we are having the V. Okay, and we are having, if you are seeing here, I1, I2, I3. Now we are just, what we are going to do for finding the value of current, for finding the value of amps, so we are just combining this current, we are just taking the sum of the currents amps. So here I am taking I1, I2, I3. Okay, so I1 plus I2 plus I3 will be the first equation. Now what will be the second equation over here? The second equation will be, if we are just if V is the potential difference across the each conductor, then I1 will be equal to V upon R1, and I2 will be V upon R2, and I3 will be V upon R3. Okay, so here what I am trying to say is, what is I1 over here? What is I1? According to the circuit, according to the Ohm's law, we are going to take V is equals to R. Okay, here we are taken, this is according to the Ohm's law. Okay, now what we are going to take, I1 is equals to what? How to take out I1? The current in the first resistor. So here we have the formula for it, I1 plus V upon R1. Okay, for second one we have I2 is equals to V upon R2, and I3 is equal to V upon R3. Okay, from the equation 1 and 2, what we get? We get that I is equal to V R1 plus V R2 plus V R3. Okay, so here we get this thing from the first to how. So if we will combine these two equations, then we will get this thing over here, you can see. So this is I. So what is the value of the current will be is written over here. The current flowing in the circuit, the current flowing in the circuit will be taken out from this formula. Okay, now if we are going to take the another, here we are going to take something else now. So but over here, but I is equals to V upon R, where R is the combined resistance of parallel system, where R is the combined resistance of the parallel system. Okay, okay, so here what we are going to get is, so guys, make sure that you subscribe to my channel, like this video and share it everywhere, and support me as much as you can. Thank you for watching my video. Thanks a lot.